Okay, guys, hey, we got a lot to cover, a short class. What is the definition of a circle, guys? Right. It's the set of all points that are equidistant from one point, that point called the center. That's what a circle is. What's the definition of an ellipse? Right. Yeah, it's a set of all points equidistant from 2 points, okay? So remember when we drew a circle, excuse me, an ellipse. Okay, guys, everybody up here, okay? When we drew the ellipse, we had two special points here that were fixed. And so if we draw the ellipse, something like this, we go up and do the other half, something like this. That's what made an ellipse. So it was an oval shape, the set of all points that were equidistant from the same point. So if I draw it here, so you've got it on the diagram, it was something like this. What were these 2 points called? Yeah. So these were the 2 focal points. That made this a vertex. What was this point right here? Covertex, covertex, okay? That's what an ellipse looks like, and it had a center, which was right there. Okay, those were all the points, okay? What was the horizontal axis? That would be the what? In this one. Major, the vertical would be minor, and what was the equation? What's the equation of this guy? Yeah, x minus h squared over a squared. Yeah. Yeah, that's the equation of an ellipse in standard form. So with an ellipse, the definition is when you add these two distances together, they are constant no matter where you go, okay? Now, let's just take, for example, suppose that these two distances add to 10, okay? What do you know about these two? Like if this was a string, okay? If the length of the string was 10, what do you know about both of these numbers? They're what? They don't have to be equal, but they have to add to what? 10. So they could be 3 and 7, 2 and 8, okay? Could one of those numbers be 11? It cannot, because this is bound. This is 10. So when you add these things, you always get 10 if this string length were 10, okay? So you add them up and they get a constant distance. Now, here's the difference between an ellipse and a hyperbola, which is the next one we're going to do. So with a hyperbola, the section that you're taking is just a horizontal section you see here that cuts through both sections of the cone. The definition of hyperbola is the set of all points such that the difference from the distance of the 2 points is constant. So instead of this one with the ellipse, this distance plus this distance is constant. They're always the same. With a hyperbola, it's going to be a distance minus a distance is going to be constant. Now think about the ellipse. If this string were 10 inches in length, those numbers always have to add to be what? Add to be 10, okay? So why doesn't 15 work? It won't work. I can't add a number to that and get 10, a positive number. Now, what if I told you that the difference has to be 10? Are there any limitations on that? Two numbers and their difference has to be 10. Can a number be greater than 10? Yeah, 20 and 10, 30 and 20, 40 and 30. So I can keep going on all day long finding numbers whose difference is equal to a particular constant. So with a hyperbola, you're not going to have a bound structure like this. It's going to be open, sort of like a parabola. Now, what you can think of, let's just suppose, for example, if I were to cut this in half. Suppose I were to cut this ellipse in half and then use your imagination and just fold it out. So basically just expand it out like this. I would get something that looks like this. Okay, if I were just to cut the ellipse open, that's basically what a hyperbola is going to be. Okay, so it's basically taking this ellipse. If you were to take it and like to cut it in half and just flip the sides, this is what a hyperbola is going to look like. Okay, we'll get into more of the details from there. But what do you notice immediately about? It's still going to have a center. Okay. What do you notice about the other points? Yeah, so here I have a center, a focus, and a vertex. Here I have a what? Center, vertex, and focus. Okay, so the order is a little bit different. Okay, so let's get into what the formula looks like. Here's the formula for a hyperbola. Okay, we're going to have two varieties. This is horizontal, this is vertical. How is that different from an ellipse? What's different? The only difference is you see a minus here. Like, for example, that is an ellipse with a plus sign there. If I take it out, it's a hyperbola. Okay, this is a hyperbola. What is the difference between these two formulas? It's like who got the negative sign. Okay, whichever one has the positive sign. If x is positive, it's horizontal. If y is positive, it's vertical. Okay, that's a little bit different than the ellipse, because with the ellipse, how did I know if this was vertical or horizontal? Yeah, which was greater? So if A is greater horizontal, B is greater vertical. Okay, so a little bit different with the hyperbola. And this is, it will show you in your book, but this is what a horizontal hyperbola looks like. I've got a center, I've got a vertex, a focus, vertex, focus, and I've got these asymptote lines that the graph does not cross. This is a horizontal ellipse, horizontal hyperbola. So this is the one that's x minus h squared over a squared minus y minus k squared over b squared equal 1. The vertical ellipse, vertical hyperbola, is just y minus k squared over b squared minus x minus h squared over a squared equal 1. So whichever one is positive dictates horizontal, vertical. Okay. Now the next page goes into more detail, and I think so far in this unit you haven't been studying this, have you? Like this, I don't find this a good page to study. I think what you do is you work these problems, and over time you get the feel and the rhythm, rather than having to memorize this. But this is what a horizontal hyperbola is going to look like. You'll have a center, and then when you go over the distance of k, and over the distance of a, you get to a vertex and a vertex. C will take you to a focus. Remember, C is the focal length. Okay, you're going to have this, and then A and B are going to help you to draw this rectangle or this box. And when you connect the center with each of these four vertices, that's when you get these asymptote lines. Okay, and those are just points or lines the graph will not cross. And here's the other point you've got to know: those asymptotes have equations. It's always direct, regardless of whether it's horizontal or vertical. It's going to be y minus k is plus or minus b over a times x minus h. Okay. Now the other thing is, when you look at this, when you've got the vertex and the focus, the axis that goes right through here is called the transverse axis. Okay. So that is my transverse axis. And then I have another axis that goes vertical here. That is my conjugate axis. If you look at a vertical hyperbola, same terminology, but it changes. The vertical is now my what? Yeah, that's my transverse axis, the one that has the vertices and the foci. And then the axis that goes right here, that is the conjugate. And the only thing that changes, like I said, for this to be vertical, the y term is positive, the x term is negative. Equation of the asymptotes, always the same. Okay, so let's just dig in, do a few examples, and you'll get to see how this works. So, vertical, horizontal, what do you think? This will be like the interactive portion where the teacher says a question, the students respond. Horizontal. So, what's the form for a horizontal hyperbola? X minus h squared over a squared minus y minus k squared over b squared equal 1. So whichever term is positive tells me what this is. This is a horizontal hyperbola. Where's the center? Yeah, this one is centered at 0, 0. And the direction of opening, we've already talked about. This is a horizontal because the term that has the positive is the x term. So the vertices and the foci will all lie on a horizontal line that goes through the center. What is A? A is 9. What is B? 4. Okay. At this point, when I know the center and I know A and I know B, there's a lot I can graph. The center is where? 0, 0? Okay, what is A? A is 9, so it means I go to the right 9 and I go to the left 9. Okay. And then B is what? 4. It means I go up 4 and I go down 4. Okay. And then what I will do next is let's just make a box out of this. And now let's draw the asymptotes. They come from the center and they go through every corner. Now, which of these points are vertices? Yeah, it's the ones on the left and the right of the center. Why is it not the ones that are top and bottom? Because this is a horizontal. So you know enough now to graph it. It's just like this. That's it. Okay? That's the graph. Now, the other thing we need to find the foci. So in order to do that, for the focal length, it's c squared. It's a little bit different than with the ellipse. This is c squared equal a squared plus b squared. You'll probably like working with this one better because there's not that minus sign and there's no absolute value. So in this case, c squared is going to be equal to 81 plus 16, which is what? 97. So c is equal to the square root of 97. So where are the foci? Where are they going to be? This is the center. That's a vertex. That's a vertex. Where will I find a focus on a hyperbola? On which side of the, so like, yeah, it's going to be over here and over here. Square root of 97 is close to the square root of what? Square root of 100 is 10, right? So this is a number that's slightly less than 10. So it's very close here. So somewhere right in here and somewhere right in here. Those are my two focal points. And exactly what are they? So it's what? The first one is what? Square root of 97, 0. What's the other one? Negative square root of 97, 0. Those are the two focal points. And for the asymptotes, we have a formula, y minus k equal plus or minus b over a x minus h. Do you know all of those things? Do you know h, k, a, and b? That would be a yes. What is k? Come on, guys. K is 0. So y is equal to plus or minus, what's b over a? So this is what, 4/9? And then what is h? H is 0. Okay? So those are the equations of the two asymptotes. Y is equal to plus or minus 4/9 x. So how does this feel compared to an ellipse? So what? Okay. Well, like I said, if I had just thrown you in this in day one, you'd be a little bit overwhelmed. But think about it, what you know. You already know what H and K is. You know what A is. You know what B is. The only thing that's different here is instead of this having a positive, you have a negative sign. So that just changes things a little bit. You already know what a vertex is, a focus, a center, all of those things. Focal length, just a couple of changes. Remember, our formula for focal length has changed when we get to a hyperbola. We also have this equation for the asymptotes that is different. And then the way we know it's vertical versus horizontal is whichever term has the positive, which was a little bit different. How did I know that this was, again, how do you know if it's a vertical or horizontal ellipse? It's just A or B, whichever one is greater. So if A is greater, that's horizontal, B is greater, that's vertical. So a little bit different in the positive, negative. Okay, let's look on another example. So let's look at this. Is this horizontal or vertical? Vertical. How do I know it's vertical? Yeah, so the y is the positive value. So I know that the standard form is going to be y minus k squared over what? B squared minus x minus h squared over a squared equal 1. What is the center of this particular one? Negative 2, negative 8. So I heard some people wanting to say negative 8, negative 2. You got to be careful here. It's the x value that goes first. So negative 2, negative 8. This direction is what? We established that this guy is vertical. So the vertices and the foci will lie on a vertical line that goes through the center of this hyperbola. What is A? A is 12. What is B? 6. Okay. When you know the center and you know A and B, in reality, you know enough to graph everything except the two focal points. Okay. So let's graph the center at negative 2, negative 8. So that is right here. So that is my center. A is what? What's A? Come on, guys. A is 12. So that means go left or right 12. So if I'm at negative 2, if I go to the right 12, that puts me at 10. If I go to the left 12, that puts me at negative 14. Okay? And B is 6. So if I go up 6 and down 6, okay, all I do next is now I draw a box that connects all of these values. So the box is really not part of the graph, but it helps you in drawing the asymptotes and framing where the hyperbola needs to go. So once I've got this box, I can draw the asymptotes. They go from the center through every vertex of the rectangle. Now again, this was vertical or horizontal? This is vertical. So this hyperbola looks just like this. And then what's the only other thing I don't know at this point? The foci. So I know that the focal length is c squared equal a squared plus b squared. So c squared is going to be equal to 144 plus 36. So that is c squared equal 180. And to simplify 180, let's see, that's 2 times 90, which is 2 times 45, which is 3 times 15, which is 3 times 5. So this is what, 4 times 9? This is 36 times 5. So the square root of 36 times 5, what does that simplify to be? 6 root 5. Okay. So C is equal to 6 root 5, and let's just get an approximation, 13.4. So C is about, okay. So by definition, C is always the distance from where to where? C is always the distance from where to where? A center to a focus, okay? So where are the focus or the foci, where are they going to be on this thing? Up or down, left or right? Up or down is going to be up here. So this is what? Negative 8 plus about 13. So that's going to be about what, 5 something? So somewhere up in here is going to be a focal point. And then this is at negative 8. Negative 8 minus 13-ish is going to be what? negative 21-ish, so somewhere down in this area right here. So I'm not too hung up on, was it right here, was it right here, I'm not too hung up on precisely that, but I do want to know exactly what those points are. So how do I find this point? It's this point plus what? 6 root 5. So it's going to be negative 2, negative 8, what? Plus 6 root 5. That's one of the focal points. What's the other one? Negative 8 minus 6 root 5, okay? So I use that focal distance C to say, I'm at the center. I go up that distance, I go down the distance. What if it had been horizontal? What would the focal points be? If I needed to travel horizontally this distance, what would these points be? Yeah, negative 2 plus 6 root 5, and then negative 2 minus 6 root 5. What's the equation of the asymptote? Y minus k is equal to what? Yeah, plus or minus b over a x minus h. So in this case, it's what? Yeah, y plus 8 equal plus or minus, what's b over a? B over a is what? 6, come on. 6 over 12. On Tuesdays, we call that 1/2, okay? X minus h is going to be what? X plus 2. Guys, don't miss points on this. This is just know the formula, plug in the 4 numbers. There's no algebra there, okay? I could have Microsoft Word, find and replace, could do that, okay? Find A, and instead of A, plug in, 12, okay? Okay, one more, and I think we're done for the day. What have we typically done? So when we did ellipses, we did day 1 of graphing. What did we do day 2? Writing equations. What do you think we're doing on day 1 of hyperbolas? What do you think we're doing day 2? Writing equations, okay? So there's graphing and there's writing equation, 2 big skills in all of these, okay? So, horizontal, vertical. Vertical because the y is positive. So the form that I'm going to use is y minus k squared over what? B squared minus x minus 8 squared over a squared equal 1. Okay? Where's the center? Nope. The center is 1, negative 1. Okay? So, y'all don't listen to Andy on that one. So the center is 1, negative 1. Okay? Be careful with that. The direction of open, we already determined this one is vertical. What is A? What is B? 8. If I know the center and I know A and B, guys, you've got 90% of what you need. So don't mess up from here. You've got 1, negative 1. That's my center. If A is 11, that means I go left and a right 11. If I'm at 1, when I go right 11, where do I end up? I end up at 12. If I go to the left 11, I end up at negative 10. Okay. Up and down, I need to go up 8. So that's going to take me to 7. And if I go down 8, that's negative 9. What do I do next? I connect the dots, okay? So I just draw a box that connects all of those points. What do I do next? Draw the asymptotes. That's from the center going through every vertex of the rectangle. Is this guy horizontal or vertical? This is vertical, so I go ahead and I can graph it. It looks like this. At this point, if I knew that it was horizontal, what would I do? What if this were this same problem? What if this were positive and this were negative? How would that change things? The center doesn't change, A and B do not change, but what would change when I get to this point right here? I would be graphing over here and over here. That's the only change. Let me take that off of this problem. So what's the thing that's left to find? The foci. Okay, so AC squared is equal to what? What if this were ellipse? What's C squared? Absolute value of A squared minus B squared. Okay, so here C squared is 121 plus 64. So C squared equal 185, and that is 5 times 37, so that's all I'm going to be able to do with that. C is the square root of 185. So the focal points, the foci, are they going to be vertical or horizontal? How am I going to find them from the center? Yeah, so it's going to be whatever this point is, it's this point plus C and this point minus C, okay? So what's the one plus C? What point is that? How do I go up the value of C from the center? It's 1, negative 1, what? Plus root 185. What's the other one? Yeah. Those are the two focal points. Okay. And what is the square root of 185? It's what? 13.6. So if I subtract, that's about 12.6. So negative 1. 12.6 is somewhere up in here. And then negative 1. So 10, 11, 12, 13, somewhere down in here is the other one. And again, I'm not too concerned about was it here, was it here, was it there. I want you to get them exactly, okay? And then you know that it's located. If that's a vertex, you know it's there. What I don't want to see is a focal point that is right here underneath the vertex, okay? You know that it goes outside in the case of a hyperbola. What's the equation of the asymptotes? Yeah. Yeah. This is one of those that, people miss this all the time last year, but if you know that formula, this part, there's not a whole lot of arithmetic or algebra. So this is going to be what? Y plus 1 equal plus or minus. What's B? B is what? You're going to make me scroll up and see. 8 over 11, right? So 8 over 11, x minus 1, right? Okay. And that's it. Okay.